Hi everyone, welcome back to another beautiful episode of Just Ask Sage. In our last video, we learned how to find the adjoint of a matrix. So today we are going to use that adjoint to find the inverse of a matrix. I'm going to teach you how to find the inverse of a matrix using not just one but two methods, using the adjoint method and the Gauss-Jordan elimination method. Before we continue, we need to know that you can only find the inverse of a matrix if the determinant of that matrix is not zero. That means before finding the inverse of a matrix, so that you will not waste your time, first of all, look at the matrix, find the determinant. If that determinant is zero, then there is no need to find the inverse. It does not exist. The inverse only exists if your determinant is not zero. So let's start off with the 2 by 2 matrix. Alright, so let's move over to how to find the inverse of a 3 by 3 matrix. These are matrix and these are our adjoints from our previous video. So the formula still remains the same. The inverse still remains 1 over your determinant times your adjoint. So let's get determinant for our 3 by 3 matrix. Remember, our determinant for A here will simply be, you start with your first entry, which is 1. Your 1 will be, close first row, first column, 1, 4, 6, 0. Then minus second entry, 2. Then it will be 0, 5, 4, 0. Your last entry, plus 3, then 0, 5, 1, 6. So that means your determinant of A will now be 1 multiplying 1 times 0, 0, minus 4 times 6, 24. 1 multiplying minus 24. Then minus 2 multiplying 0 times 0, 0, minus 20, minus 20. Then plus 3 multiplying 0 minus 5, minus 5. So this will give us negative 24 plus 40 minus 15. And that is going to give us negative 24 minus 15, negative 39, plus 40, 1. So that means our determinant of this whole matrix is 1. So therefore, our inverse of this matrix will now be 1 over 1 times your adjoint. That is times negative 24, 18, 5, 20, negative 15, minus 4, minus 5, 5, 1. Now, since our entry outside 1 over 1 is 1, we multiply everything. Remember, if you multiply anything by 1, it will still give you back the same number. So therefore, our inverse will still remain the same. It will be negative 24, 20, negative 5, 18, negative 15, 5, 5, negative 4, 1. And we are done. Alright, so let's learn how to find the inverse of a matrix using the Gauss-Jordan elimination method. So first of all, we have to assign the identity matrix beside our matrix. That's our identity matrix for this 2 by 2 will be 1, 0 and 0, 1. So now we have the left hand side of the matrix and the right hand side of the matrix. So the goal is that we have to change this left hand side of the matrix to the identity matrix. That it should look something like this. We're going to do that using elementary row operations. So we are going to call this row 1, and we're going to call this row 2. Now, our elementary row operations that we are going to perform are, we have row swapping, like exchanging of rows. We have multiplying a row by a constant and row replacement. So I want to first of all swap these two rows. Reason is that so that this entry now will become 1. So I want to first of all interchange row 1 and row 2. It will now be 1, 4, 0, 1 and 2, 3, 1, 0. That means this our new row 1. I'll call it row 1 prime. Our new row 1 was a former row 2. Then our new row 2 prime was a former row 1. Now, the next step, to make a look at the identity matrix, we have to change here to 0. And what operation do we need to perform to change here to 0? If here was 2, you can easily subtract to change here to 0. So the operation we are going to do is 2 times this minus this. So first of all, our row 1 is not going to change. Write it out first. It's going to remain the same. That means our new row 1 prime prime, didn't change, or simply our row 1 prime. But our row 2 prime prime, that's our new row 2. What we're going to do is 2 times this, 2 times the old one minus this, was what was supposed to give us 0. That is 2 row 1 prime minus row 2 prime. And that will give us 0 here. But it's going to affect the entire row. So that means you are doing 2 times 4, that's 8, minus 3 to give us 5 here. 2 times 0, 0, minus 1, negative 1. 2 times 1, 2, minus 0, remains 2. Alright, so the next step now is that I want to change here to 1 and change here to 0. Let's start by changing here to 1. To change this place to 1, we simply have to multiply here by 1 over 5. And remember, it has to affect the entire row. So that means our new row 2, our row 2 prime prime, prime will simply be gotten by multiplying by 1 over 5. That's 1 over 5 row 2 prime prime. And that will give us 0 times 1 over 5, 0. 5 times 1 over 5, 1. Then this will be negative 1 over 5, and here will be 2 over 5. Let me not change this first. This will remain the same. That means our row 1 prime 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 is simply row 1 prime prime. Alright, so lastly, this looks like our identity matrix, but the last thing we need to do is to change here to 0. And how do we change here to 0? If here was 4, you simply do 4 minus 4 will give here 0. So what we'll do is 4 times this minus this, that will give us our 0. 4 times this. No, sorry. If I do that, it's going to affect this one here. Rather, let's go from here to here. Just do this minus, this minus 4 times this. That way it won't affect this one here. So what I mean is that our new row 1, first of all, our row 2 remain the same. It remains 0, 1, negative 1 over 5, 2 over 5. That's our row 2 prime 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 is simply row 2 prime prime prime. But our row 1 prime 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 prime, I said just do this minus 4 times this. That is row 1 prime 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 minus 4 times row 2 prime prime prime. This way, 1 minus 4 times 0 will still give us 1. That's why I said we should do this, so it won't affect this one. Then 4 minus 4 times 1, this will now give us 0. 0 minus 4 times minus 1 over 5, that should be should give us 4 over 5. Then lastly is 1 minus 4 times 2 over 5. That's 1 minus 8 over 5. That should be giving us negative 3 over 5. So now that we've turned our left-hand side to an identity matrix, our inverse of a matrix, A inverse, will be what is left in our right-hand side. So that means our inverse of this, our initial matrix here, will simply be 4 over 5, negative 3 over 5, negative 1 over 5, 2 over 5. So let's find the inverse of this 3 by 3 matrix using the Gauss-Jordan elimination method. As you can see, I've already written the identity matrix beside it. So what is left for me to do is that I should change this left-hand side to look like this right-hand side. As you can see, this is already 1. Our first entry is already 1. So we're not going to touch our row 1. Our second entry here is 0. So we're not touching row 2 either. But this row 3 that is 5, we have to change it to 0. So that means now next thing we're going to do, our row 1 is not changing. 1, 2, 3 to remain 1, 0, 0. That means our row 1 prime, our new row 1 was our old row 1. Our row 2 also is not changing to remain the same. So that means row 2 prime is simply row 2. Then it's our row 3 that's going to change. Our row 3 prime. Our row 3 prime. To change here to 0, you simply need, you are going to use this one to change this to 0. So you simply need 5 to be here, so you subtract. So that means you are doing 5 times this minus this. That will change here to 0. That is 5 times row 1 minus row 3. If we do that, this will now be 0. Now, 5 times 2, 10, minus row 3, that's minus 6. This will be 4 now. 5 times 3, 15. 15 minus 4, that will give us 11. Then 5 times 1, 5. 5 minus 0, 5. 5 times 0, 0. 0 minus 0, 0. Then 5 times 0, 0. 0 minus 1, negative 1. Alright, so now the next step is this. This place is already 1. We're not going to change this. So all we have to do is that we need to change this and this to 0. So that means our row 2 is going to remain the same. 0, 1, 4, 0, 1, 0. So that means our row 2 prime prime is simply row 2 prime. Now to change these two places to 0, we're going to use this to change itself to 0. So assuming we had 2 here, it would have just been 0, Abi. So I'm just going to do 2 minus 2 times this. That will give us 0. And if that way, it's not going to affect this one that is here. So that means our row 1 prime prime will simply be row 1 prime, that's this, minus 2 times this, that's minus 2 times row 2 prime. So if you do that, you have 1 minus 2 times 0 to remain 1, doesn't affect it. 2 minus 2 times 1, this will now be 0. 3 minus 2 times 4, that's 3 minus 8, negative 5. 1 minus 2 times 0 remains 1. 0 minus 2 times 1, that's negative 2. 0 minus 2 times 0 remains 0. Now our row 3 prime prime. To change here to 0, you simply need 4 to be here. It can be this minus this or this minus this. Whichever way, it won't affect our zeros here. So we can just say 4 times row 2 prime minus row 3 prime. So 4 times 0, 0 minus 0 remains 0. Doesn't affect. 4 times 1, 4. 4 minus 4. This place now changes to 0. 4 times 4, 8. 8 minus 11 changes here to negative 3. 4 times 0, 0. 0 minus 5, negative 5. 4 times 1, 4. 4 minus 0, 4. 4 times 0, 0. 0 minus negative 1, this will give us normal 1. Alright, so in our last column now, what's left is that here should be 0, here should be 0, and here should be 1. So I want to start by turning here to 1 by multiplying by negative 1 over 3. So in our next entry, these our first two rows are not going to change. It will remain 1, 0, negative 5, 1 minus 2, 0, and 0, 1, 4, 0, 1, 0. This will then be that our row 1 prime 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 remains row 1 prime prime. Row 2 prime 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 remains row 2 prime prime. Then like I said, our row 3 is what is going to change. And our row 3, remember I said I was going to multiply by negative 1 over 3 so that it would turn here to 1. So that is negative 1 over 3 times row 3 prime prime. Then if I do that, 0 times negative 1 over 3, 0. 0 times negative 1 over 3, 0. Minus 3 times negative 1 over 3, 1. Minus 5 times negative 1 over 3. This will turn to 5 over 3. 4 times negative 1 over 3 will turn to minus 4 over 3. And 1 times negative 1 over 3 will turn to minus 1 over 3. So what's left now is to turn here and here to 0. And we have to use this one now to turn them to 0. So for this one, for this first row, to turn it to 0, we just need 5 to be here. Then you add them. It's now turned to 0. It can be this plus this or this plus this, whichever way you want to do it. It's not going to, well, it may affect. The only way it won't affect is if you do this plus this. Okay, so what we're going to do is that we are doing negative 5 plus 5 here. So what I mean is that our row 1 now, that is row 1 prime 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 prime, will be row 1 prime 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 plus 5 times this, that is plus 5 times row 3 prime prime prime. All right, so if we do that, 1 plus 5 times 0 remains 1, didn't affect it. 0 plus 5 times 0 remains 0, didn't affect it. Negative 5 plus 5 times 1, this will now turn here to 0. 1 plus 5 times this, that's 1 plus 25 over 3. 1 plus 25 over 3 should give us 28 over 3. Okay. Negative 2 minus 5 times this, 20 over 3. That's minus 6 minus 20. This should give us negative 26 over 3. All right. Now, 0 plus 5 times this, that will give us negative 5 over 3. All right. Now, we need to change here to 0. This is not going to change. This is our last row. We are done with our last row. So our last row, row 3 prime 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 prime, didn't change. It remains row 3 prime prime prime. But it's our row 2 now, row 2 prime 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 prime, that we need to work on. To change here to 0 in such a way that it won't affect is that you need 4 to be here and you need to subtract. So what we're going to do is that we'll do this minus 4 times this. That is row 2 prime 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 minus 4 times row 3 prime prime prime. If we do that, 0 minus 4 times 0, 0. 1 minus 4 times 0, 1. 4 minus 4 times 1, 0. Okay, 0 minus 4 times this, that is negative 20 over 3. 1 minus 4 times this will give us 1 plus 16 over 3. And this should be giving us 19 over 3. 0 minus 4 times this, that's 0 plus 4 over 3. That will give us 4 over 3. So as you can see, we have been able to turn here to an identity matrix. So therefore, our inverse matrix will now be 28 over 3, negative 26 over 3, negative 5 over 3, negative 20 over 3, 19 over 3, 4 over 3, 5 over 3, negative 4 over 3, and negative 1 over 3. This is our answer. All right, everyone. So with this, we've been able to conclude our marathon of matrices and determinants. Wow, 6 whole episodes. That's insane. So do comment what you think our next topic should be. But for now, we're going to take a little break. Take a break. Matrices and determinants, it's not been easy. Take a little break. But what our next comment should be, do let me know. So our next video will start a whole new topic entirely. Bye guys. Sage out.